The cold comes first, always the cold. It seeps through the stone walls of the tower, through the wooden shutters left open to the night, through the layers of wool and linen wrapped around your body. Medieval cold is different from the cold you know. It is patient, relentless. It does not rush. It simply exists, a fundamental quality of the world after the sun has gone, and you must exist within it or not exist at all. You are standing at the highest point of the monastery. The tower rises above the scriptorium, above the church, above the cloisters where your brothers sleep in their cells. Below, far below, the village is dark. A few embers glow in hearths, but most fires have been banked for the night. The people sleep under thatch and timber, under wool blankets and animal skins, their breath clouding in the darkness of their homes. They do not know you are up here. They do not think about what you are doing. They sleep, and you watch. The year is somewhere in the 13th century. Let us say 1247, though the exact year does not matter as much as you might think. Time moves differently in this era. The church counts the hours of prayer. The seasons count the planting and the harvest. The stars count something else entirely, something older and more precise than either. You are here to read what the stars have written. The tower platform is small, perhaps 10 feet across, perhaps 12. Stone flags beneath your feet, worn smooth by centuries of footsteps, though not many come up here. This is your domain. The walls rise to waist height, giving you something to brace against when the wind picks up, which it does often at this elevation. Beyond the walls, there is nothing but air and night, and the rolling darkness of the landscape, hills and forests rendered invisible by the absence of light. But above is everything. You tilt your head back and look up at the firmament. This is what they call it, the firmament. The word feels heavy in your mind, solid, like the thing it describes. The medieval understanding of the cosmos is not your understanding. They do not think of space as you do, as an infinite void scattered with distant nuclear furnaces. They think of spheres. Crystal spheres, nested one inside another, each one carrying its planets and stars in perfect circular motion around the Earth, which sits motionless at the center of creation. The outermost sphere is the firmament, and it is where the fixed stars live. Fixed because they do not wander like the planets do. Fixed because they hold their positions relative to one another, night after night, year after year, century after century. The same patterns your ancestors saw. The same patterns their ancestors saw. The same patterns, they believe, that Adam saw when he first opened his eyes in the garden. But the stars are not just lights to them. They are holes, punctures, perforations in the floor of heaven, through which the light of the divine realm shines down into the darkness of the sublunary world. Every point of light you see is a glimpse of eternity, of the realm beyond the material, beyond the corrupt and changing earth. The light is pure, unchanging, perfect, and it falls on you, standing alone on this tower in the middle of the night, trying to measure it. The sheer number of stars visible is staggering. You have never experienced true darkness, not the way they do. Even on the darkest night in your time, there is light pollution bleeding across the horizon from distant cities, a diffuse glow that washes out the fainter stars. Here, there is nothing. The nearest city is days away by horse, and it is small, and it is dark. The villages are dark. The monasteries are dark. The entire world is dark except for the stars. You see them all, thousands upon thousands of points of light, so dense in places that they blur together into a luminous fog. The Milky Way is not a faint smudge. It is a river of light arching across the entire sky, so bright it casts shadows, so detailed you can see the dark rifts and channels running through it. You can see stars that your eyes in your own time would never detect, fourth magnitude, fifth magnitude, sixth magnitude stars that form the subtle connections between the major constellations. The constellations themselves are overwhelming. You know them, of course. You have studied them. But knowing and seeing are different things. Orion dominates the southern sky, his belt perfectly straight, his sword hanging below it, the great nebula a fuzzy patch that medieval eyes interpret as cloud or mist. Taurus charges toward him, the Pleiades clustered on the bull's shoulder like a swarm of celestial bees. Gemini stands side by side. Canis Major follows at Orion's heel, Sirius blazing like a blue-white diamond. To the north, the circumpolar constellations wheel around Polaris in their eternal dance. Ursa Major, the Great Bear, though the monks call it the plough or the wain, seeing farming tools where the Greeks saw a beast. Ursa Minor, the Little Bear, with Polaris at the end of its tail. Draco snakes between them. Cassiopeia sits on her throne, a bright W in the sky. Cepheus stands nearby, dimmer, harder to trace. You have been taught that these patterns are not accidents. They are not random arrangements of unrelated objects. They are signs. The heavens declare the glory of God, the psalmist wrote, and the firmament showeth his handiwork. Every constellation is a letter in a divine alphabet. Every movement of the planets a word in a cosmic scripture. Your job is to read it, to decode it, to extract meaning from motion and light. But first, you must measure. You reach into the leather satchel at your side and withdraw the astrolabe. It is heavy, heavier than you expect every time, even though you have held it hundreds of times. The weight is reassuring, substantial, real. It tells you that this object is valuable, important, worth the months or years of labor it took to create. The astrolabe is made of brass, cast and carved and engraved with extraordinary precision. It is a flat disc, slightly larger than your palm, perhaps 5 inches in diameter. The brass has aged to a deep golden color, darker in the recesses of the engravings, brighter on the raised surfaces where your fingers polish it with repeated handling. It is not perfectly smooth. You can feel the grain of the metal, the tiny irregularities left by the craftsman's tools, the slight roughness of the engravings. The disc hangs from a ring at the top, a thick loop of brass called the throne, and from the throne hangs a smaller ring meant for your thumb. This is how you hold it. This is how you ensure it hangs perfectly vertical, perfectly plumb, aligned with the axis of the Earth and the cosmic spheres above. The front face of the astrolabe is intricate beyond belief. At first glance, it looks impossibly complex, a maze of circles and lines and pointers and scales, all layered on top of one another. But you understand it. You have studied it. You have memorized every line and every marking. You could operate it in total darkness if you needed to, though tonight you do not need to. Tonight the stars provide more than enough light. The base plate, the mater, is engraved with circles and scales around its rim. These mark the hours, the degrees, the azimuths. In the center, the mater is hollowed out into a shallow dish, and sitting in this dish is a second plate, specific to your latitude, engraved with more circles representing the altitude of the sun at different times of year, the boundaries of the houses, the curves of the unequal hours. And on top of everything, rotating freely on a central pin, is the reedy. The word means net or web, and that is exactly what it looks like. It is a delicate skeleton of brass, cut and filed into an openwork pattern of curves and pointers. Each pointer represents a star, and the pattern they form, when properly aligned, is a map of the night sky as seen from your position on Earth. The reedy can rotate to show the sky at any hour, any day, any season. It is beautiful, not in the decorative sense, though some astrolabes are decorated lavishly with gold inlay and precious stones. This one is plain, functional, a tool for work. But the beauty is in the precision, in the elegance of the design, in the way this flat disk of metal contains within it the entire rotating heavens, compressed into 2 dimensions, made portable and comprehensible and useful. You lift the astrolabe by its ring and let it hang from your thumb. The weight settles. The disk finds its plumb line, perfectly vertical. You can feel the pull of the Earth through the metal, the same force that holds the moon in its orbit, that makes the rain fall and the rivers run downhill. Gravity, though you do not call it that. You call it the natural motion of heavy things seeking their proper place at the center of the cosmos. On the back of the astrolabe, projecting from the center, is the alidade. It is a long brass bar with a pointer at each end, and two small rectangular sights mounted perpendicular to the bar, each sight pierced with a tiny hole. You can rotate the alidade around the center pin, and when you look through the holes in the sights, they align your eye with the pointer, creating a precise line of sight to whatever celestial object you wish to measure. You turn slowly on the tower platform, holding the astrolabe in front of you, feeling the cold bite of the metal against your thumb. You are looking for Polaris, the North Star, the one fixed point in the wheeling heavens, or nearly fixed. It is not exactly at the pole in this century. The precession of the equinoxes has shifted things slightly, and Polaris orbits the true celestial pole in a small circle, but it is close enough to serve as the anchor for all your measurements. There you see it. Not the brightest star in the sky by any means. Sirius is brighter, Vega is brighter, Capella is brighter. But Polaris occupies a unique position, and that makes it more important than brightness ever could. It is the pivot, the axis, the still point around which everything else rotates. You raise the astrolabe higher, bringing it up to eye level. The metal is so cold now that it hurts to hold, the brass pulling heat from your skin faster than your body can replace it. Your fingers are going numb. This is normal. This is expected. You have learned to work through it, to maintain your grip and your precision even as sensation fades from your fingertips. You look through the holes in the alidade sights, adjusting the angle, rotating the bar until Polaris appears through both holes simultaneously, perfectly aligned. It takes patience. The holes are small, and your hands are shaking slightly from cold and fatigue. You rotate the alidade a fraction of a degree, too far, back, closer, almost, there. The star sits in the center of both holes, a point of light framed by brass. You freeze, holding your arm as still as possible, barely breathing. The astrolabe sways slightly on its ring, responding to the tremor in your muscles, but you compensate, making tiny adjustments, keeping the star centered. Your thumb aches from the weight. Your arm aches from holding it extended. You ignore both. Click. The sound is imaginary, but you hear it anyway in your mind. The satisfying sensation of alignment, of precision achieved, of order imposed on chaos. The alidade is locked onto Polaris. You are connected now, through metal and air and light, to that distant point in the heavens, and through it to the pole itself, the axis around which the entire cosmos rotates. Carefully, very carefully, you lower your other hand to the alidade and hold it in place, pinching it between thumb and forefinger so it cannot rotate. Then you lower the astrolabe from eye level and look down at it, at the scale engraved on the rim of the mater. The pointer of the alidade crosses the scale at a specific mark, and that mark tells you the altitude of Polaris above the horizon. The numbers are engraved in Arabic numerals, though you still think of them as Hindu numerals, the strange symbols that came to Europe through the Islamic scholars in Spain and Sicily. 10, 20, 30, 40. The alidade crosses at 43 degrees and perhaps one-third. Say 43 degrees and 20 minutes. That is the altitude of Polaris, and because Polaris sits at the celestial pole, that is also your latitude. You are 43 degrees and 20 minutes north of the equator, somewhere in southern France or northern Italy or the northern reaches of Spain. Not that you need the astrolabe to tell you where you are. You know where you are. The monastery has stood on this hill for 2 centuries, and it will stand for centuries more, God willing. But the measurement confirms what you know. It anchors you. It proves that the mathematics work, that the cosmos is orderly, that the laws inscribed on this brass disc correspond to the reality of creation. You rotate the alidade away from Polaris now, swinging it around to point at other stars. Aldebaran in Taurus, Betelgeuse in Orion, Rigel, Procyon. Each star has its own altitude, its own position in the sky, and each position changes throughout the night as the firmament rotates from east to west. But the reedy of the astrolabe, properly set, accounts for this. The pointers on the reedy represent the stars. And when you rotate the reedy to match the current positions of those stars in the sky, the astrolabe will tell you the time. This is not obvious. It should not work, this compression of the three-dimensional heavens onto a flat disk. The mathematics involved are sophisticated, a combination of geometry and astronomy that took centuries to develop. The principle is stereographic projection, though you do not use that term. You think of it as a shadow, a projection of the crystal spheres onto the plane of the equator, with the south celestial pole as the point of projection. Every circle on the celestial sphere projects to a circle on the astrolabe. Every star projects to a point. The entire cosmos, reduced to brass and geometry. You align the reedy now, rotating it until the pointer for Betelgeuse matches the altitude you measured. Click, slide, lock. The reedy settles into position, and now the astrolabe is configured for this specific moment in time, this specific position of the stars. You look at the outer rim, where the hour lines are marked, and you see where the pointer crosses them. The time is approximately 2 hours past midnight, the second hour of the morning, deep night. The monks will not rise for lauds for another 3 hours at least. But the astrolabe tells you more than just the time. It tells you the structure of the night itself. The curved lines on the plate beneath the reedy divide the sky into houses, the 12 divisions of the zodiac as seen from your latitude. The horizon line shows which stars are visible and which are below the earth. The altitude lines show how high each star stands above the horizon. The entire celestial sphere is mapped onto this disk, rotating, changing, living. You can see where the sun is, even though it is night and the sun is invisible. There is a pointer on the reedy for the sun's position, and you know that the sun is currently in Aquarius, moving slowly toward Pisces. The pointer shows the sun well below the horizon, on the opposite side of the earth, illuminating the lands to the east, where morning has already come. In a few hours, the sun will rise here too, and the stars will fade, and the astrolabe will become less useful for a while, though you can still use it to tell time by the sun's altitude. The cold is becoming unbearable now. You have been standing still for too long, and the wind is picking up, blowing across the tower platform with a steady low moan. You can feel it cutting through your robes, through the wool, through everything, reaching your skin and pulling the warmth away. Your face is numb. Your hands are numb. Even your thoughts seem to move more slowly, sluggish in the cold. But you have your measurement. You have confirmed the time, confirmed your latitude, confirmed the position of the stars. The astrolabe has done what it was designed to do. It has taken the vast and terrible beauty of the night sky and made it comprehensible, mathematical, useful. It has allowed you to participate in the cosmic order, to read the signs written in light across the firmament. This is what medieval astronomy is, at its core. It is not about discovery in the way you think of discovery. These monks and scholars are not trying to overturn the old models or propose new theories. They are trying to perfect the old ones, to make the measurements more precise, to refine the calculations, to bring the tables and models into ever closer alignment with observed reality. They believe the cosmos is knowable because they believe it was created by a rational God, and rationality can be understood through mathematics. The astrolabe is proof of this belief. It is reason made tangible, geometry made brass. Every line engraved on its surface represents hours of calculation, checking, refinement. The craftsman who made this astrolabe worked from tables compiled by earlier astronomers, who worked from observations made by still earlier astronomers, reaching back through the Arab scholars to the Greeks, to the Babylonians, an unbroken chain of measurement and thought stretching back thousands of years. And you are part of that chain now. Your observation tonight, your measurement of Polaris and Betelgeuse and the time will be recorded. It will be added to the growing body of data, the accumulating precision of centuries. Perhaps it will help correct a small error in the tables. Perhaps it will confirm what is already known. Either way, it matters. Every measurement matters. Every data point is a piece of the great work of understanding creation. You lower the astrolabe and let it hang from your thumb again, the metal warming slightly from your body heat, though not by much. You flex your fingers, trying to restore circulation, and feel pins and needles as blood returns to your fingertips. The sensation is intensely painful for a moment, then fades to a dull ache. You should go inside now. You should descend the narrow, spiral stairs to the warmth of the scriptorium, where a small fire still burns in the hearth, banked but not extinguished. You should record your observations while they are fresh in your mind, before the numbers fade or become confused. This is part of the discipline. The observation is only half the work. The recording is equally important. But you linger on the tower for another moment, looking up one more time at the stars. They will still be there tomorrow night, in almost the same positions, shifted slightly by the daily rotation of the firmament. They will be there next month, next year, next century. Long after you are dead and forgotten, the stars will still wheel overhead, still shine through the floor of heaven, still mark the hours and seasons for whatever monks stand on this tower in the future. There is something comforting in that permanence, something that makes the cold and the exhaustion and the numbness worthwhile. You are connecting with something eternal. You are measuring the immeasurable. You are, in your small way, participating in the divine order of creation. The wind gusts again, stronger this time, and you turn away from the battlement and toward the door that leads down into the tower. It is a low wooden door, reinforced with iron bands, heavy and solid. You have to duck to pass through it, and you do, stepping from the open platform into the enclosed space of the stairwell. The wind immediately cuts off, and the silence becomes even more profound. No wind, no rustling leaves, no distant sounds from the village. Just your breathing and your footsteps on the stone stairs. The stairs spiral downward in a tight helix, each step worn concave in the center by generations of feet. There is no railing. One wall is the outer wall of the tower, cold stone that you trail your free hand along for balance. The other wall is the central column around which the stairs coil. The space between is barely wide enough for your shoulders. It is completely dark in the stairwell. The stars do not penetrate here. There are no windows, no candles, nothing. You descend by touch and memory, counting steps, feeling for the curve of each tread, moving slowly to avoid a misstep that could send you tumbling down the hard stone spiral. The astrolabe swings from your thumb, bumping against the wall occasionally with a soft, metallic clink. 20 steps, 30, 40. Your eyes, so adapted to the starlight above, see absolutely nothing here. This is true darkness, absolute darkness, the darkness of the tomb. You could hold your hand inches from your face and not see it. You understand now why the monks speak of hell as a place of outer darkness. Darkness is not just the absence of light. It is a presence, a weight, something that presses in on you from all sides. 50 steps, 60. You are perhaps halfway down now. The stairs end in a small chamber that opens onto the scriptorium. That is where you are going. That is where the desk waits, and the parchment, and the ink, and the tools of recording. The scriptorium is the heart of the monastery in many ways, more so even than the church. The church is where the community worships, where the hours are chanted, and the masses are said. But the scriptorium is where knowledge is preserved. It is where the books are copied, where the illuminations are painted, where the margins are filled with commentary and correction. It is where the work of understanding and transmitting truth takes place. And it is where the astronomical observations are recorded in a large ledger kept for that purpose, a book of heavy parchment bound in wooden boards covered with leather. The ledger is not beautiful. It is not decorated with gold leaf or elaborate initials. It is a working document, filled with columns of numbers and dates and notes, all written in the same careful script, black ink on cream-colored parchment. You reach the bottom of the stairs and push through another door into the scriptorium. The room is large, perhaps 40 feet long and 20 wide, with a high vaulted ceiling supported by stone ribs. During the day, it is filled with light from tall, narrow windows along one wall, south-facing to catch the sun. At night, like now, it is lit only by the fire in the hearth and whatever candles the monks choose to light, which is usually not many. Candles are expensive. Tallow is expensive. Even firewood must be gathered and split and stacked. Nothing is wasted. Tonight the room is almost dark. The fire has burned down to coals, glowing deep red in the stone hearth. The heat radiates outward, but it does not reach very far. The air near the fire might be comfortable. The rest of the room is cold, only slightly warmer than the tower above or the winter night outside. You cross the room to your desk, the astrolabe still hanging from your thumb. The desk is one of several arranged along the wall, each one a simple wooden surface tilted at a slight angle, with a stool and a shelf beneath for books and materials. Your desk is near the fire, a privilege granted by your position and your years of service. Younger monks work at the far end of the room, where the cold is worse and the light is dimmer. On the desk is the ledger closed. Next to it, an inkwell, a quill, and a small knife for trimming the quill. A candle in a bronze holder unlit. A piece of chalk for rough calculations. A straight edge. A compass. The tools of your trade. You set the astrolabe down carefully on the desk, and the absence of its weight makes your thumb feel strange, light and tingly. You flex your hand again, working the stiffness out, and then you turn to the fire. There is a long splint of wood on the mantel, kept there for lighting candles. You take it and push one end into the coals until it catches fire, then bring the flame to the candle on your desk. The wick sputters and then blooms into a small yellow flame, and the light spreads, pushing back the darkness in a small sphere around you. The candlelight is warm and golden, completely different from the cold white light of the stars. It flickers and dances, casting moving shadows across the desk and the walls. It is comforting, human, but it also makes it harder to see fine details. You will have to be careful with your writing. You sit on the stool and open the ledger to the last page with writing on it. The entry is from 2 nights ago, in your own hand. Date, time, stars observed, measurements taken, weather conditions. The same information you are about to record now. There is something meditative about this repetition, this daily ritual of observation and recording. Each entry is nearly identical to the last, and yet each is unique, capturing a specific moment in time that will never come again. You pick up the quill and examine the tip. It needs trimming. The ink has dried on it and made it stiff. You take the small knife and carefully slice away the damaged portion of the feather, then cut a new nib, splitting the tip and shaping it to hold ink properly. This is a skill that takes practice. A poorly cut quill will skip or blot or wear out quickly. A well-cut quill will write smoothly for hours. You dip the quill into the inkwell. The ink is thick and black, made from oak galls and iron sulfate. It flows reluctantly in the cold, and you have to let the excess drip back into the well before you can begin writing. Then you touch the nib to the parchment and begin to form the letters. The date first. Anno Domini 1247, the 4th day of February, the feast of Saint Veronica. The time, 2 hours past midnight, measured by the astrolabe using Betelgeuse. Polaris altitude, 43 degrees 20 minutes. Weather, clear, cold, wind from the northwest. The writing is slow and deliberate. Each letter must be formed correctly, clearly, legibly. The parchment is too valuable to waste on hasty or careless work. You learned this as a novice, copying out psalms and prayers until your hand cramped and your eyes watered, until the shape of each letter was burned into your muscle memory. Now it is automatic. The quill moves across the parchment, leaving trails of black ink that catch the candlelight and glisten wetly before they dry. Stars observed, you write, and then you list them. Polaris, Betelgeuse, Rigel, Aldebaran, Procyon. For each star you record the altitude measured, the azimuth if you took it, any notes about the observation. Betelgeuse showed slight ruddy color. Sirius twinkled near the horizon. Aldebaran's steady and bright. These details might seem trivial, but they are not. Centuries from now, astronomers will use records like these to track changes in stellar positions, to refine their models of precession, to calibrate their instruments. Your observations will become data points in studies you cannot even imagine. The work you are doing here in this cold room by candlelight will echo through time. But you do not think about that. You are focused on the task at hand, on forming the letters correctly, on recording the numbers accurately. The quill scratches against the parchment with a soft, rasping sound. The candle flame flickers in a draught. The fire crackles quietly as a log shifts in the hearth. You are alone in the scriptorium. The other monks are asleep in their cells. In a few hours the bell will ring for lauds, and they will rise and shuffle to the church in the darkness, half awake, to chant the psalms and prayers. But for now, it is just you and the silence and the work. The astrolabe sits on the desk beside you, catching the candlelight on its engraved surfaces. You glance at it occasionally as you write, verifying a number, checking a detail. The brass seems to glow in the warm light, transformed from the cold instrument of the tower into something almost alive, almost sentient. It is easy to see why some people fear these devices, why they whisper about sorcery and forbidden knowledge. The astrolabe knows too much. It sees too clearly. It reduces the heavens to mathematics, and mathematics can be dangerous. But you do not fear it. You understand it. You know that it is simply a tool, brilliantly conceived and precisely made, but still just a tool. The knowledge it provides is not forbidden. It is a gift, a glimpse into the rational mind of the Creator, evidence of his wisdom and his plan. You finish recording the basic observations and pause, dipping the quill again. Now comes the more complex part, the calculations. Using the measured positions of the stars, you can check the accuracy of the astronomical tables, the predictions of where each star should be at this time on this date. You can compute the sun's position even though it is invisible. You can determine the length of the night, the time of sunrise, the position of the moon if it were visible. All of this requires mathematics. Addition, subtraction, multiplication, division, proportions and ratios, trigonometric functions, though you use tables rather than calculating them directly. The work is tedious and exacting, and there is no room for error. A single mistake in transcription or calculation can corrupt everything that follows. You draw a line across the page to separate the raw observations from the calculations. Then you begin. The sun's position first. You know from the calendar that the sun entered Aquarius on the 21st of January, and it has been moving eastward through the Zodiac at approximately 1 degree per day. Today is the 4th of February, 14 days later, so the sun should be at approximately 14 degrees into Aquarius. But the sun's motion is not perfectly uniform. The Earth is not at the center of the sun's orbit, but slightly offset, at one focus of an ellipse, though the medieval model explains this differently. They say the sun moves on an eccentric circle, a circle whose center does not quite coincide with the Earth. Because of this eccentricity, the sun appears to move faster at some times of year and slower at others. You refer to the tables in another book, a thick volume kept on the shelf beneath your desk. The tables list the sun's position for every day of the year, calculated years ago by astronomers working from centuries of observations. You find the entry for the 4th of February and read the number, 13 degrees 45 minutes into Aquarius. Close to your estimate, but not exact. The tables account for the eccentricity that your rough calculation ignored. You write this number in the ledger, along with a note about which table you used. Then you move on to the next calculation, and the next, working steadily, methodically, filling the page with numbers and symbols and notes. The candle burns lower. The fire in the hearth fades to a softer glow. The cold creeps closer, inch by inch, as the heat dissipates. Outside, the stars continue their slow rotation across the sky. Inside, You continue your work, translating celestial motions into earthly records, building the foundation of knowledge that future generations will stand upon. The calculations complete, you close the ledger carefully and return it to its place on the shelf. The numbers are recorded. The data is preserved. But the night's work is not finished. There is another task, one that requires different tools and a different kind of precision. You rise from the stool, your joints stiff from sitting in the cold, and gather the astrolabe and the candle. The scriptorium is vast and dark beyond the small circle of candlelight, full of shadows that shift and move with the flame. You walk toward the far end of the room, past the other desks, past the shelves of books and manuscripts, toward a smaller door set into the wall. This door leads to your private study, a small chamber that was once a storage room but has been given to you for your astronomical work. It is a privilege, this private space. Most monks share everything, the dormitory, the refectory, the cloister. But you need a place where you can spread out your charts and instruments, where you can work without disturbing others or being disturbed. The abbot understood this and granted you this room. You push the door open and step inside. The air here is different, warmer, more still. There is a small brazier in the corner, and you must have left coals burning in it from earlier in the evening, because a faint glow emanates from it still. You set the candle down on a table and move to the brazier, adding a few small pieces of charcoal from a bucket beside it. The coals accept the new fuel and begin to burn brighter, and you feel the heat increase, pushing back against the cold that has soaked into your bones. The study is tiny, perhaps 8 feet square, but it is yours. The walls are lined with shelves, and the shelves are filled with books and scrolls and instruments. A table occupies the center of the room, heavy oak scarred with years of use, its surface covered with the tools of astronomy. And on the wall opposite the door hangs the great star chart, the map of the heavens that you have been constructing for the past 5 years. You turn to look at it now, and even after all this time, it still takes your breath away. The chart is drawn on vellum, treated sheepskin stretched and scraped and prepared until it is smooth and white and strong. The vellum is expensive, precious, but this chart required a large piece, nearly 3 feet square, to contain all the stars and constellations you wish to map. The chart is covered with ink, black ink for the stars, arranged in their constellations, each star represented by a small circle, the larger circles for brighter stars, smaller circles for dimmer ones. Red ink for the ecliptic, the path the sun traces through the zodiac over the course of the year. Blue ink for the celestial equator and the lines of declination. Gold ink, sparingly used, for the most important stars, and for the names of the constellations, the letters carefully formed in your best script. The constellations sprawl across the vellum in their traditional shapes. Ursa Major dominates the northern portion, the bear's body and tail rendered in connected stars. Draco wins between the bears. Cassiopeia and Cepheus stand nearby. Moving south, you have drawn Andromeda and Perseus, Auriga and Gemini, Cancer and Leo, all the familiar figures that wheel overhead through the turning year. But this is not merely a decorative map. This is a working chart, a research document. Between the stars and along the margins, you have made countless annotations, measurements of stellar positions in degrees and minutes, notes about color and brightness, observations of changes, though the stars are supposed to be unchanging, dates when certain stars rose or set at particular times. Everything you have learned over years of patient observation is recorded here. And there, drawn in a different color entirely, in green ink that stands out against the black stars, is the current position of Mars. Mars, the red wanderer, Ares to the Greeks, the god of war, and the planet bears that warlike quality in its ruddy color and its erratic motion. Mars does not move like the stars. The stars maintain their positions relative to one another, rotating as a fixed sphere. But Mars moves against the stars, drifting eastward most of the time, but sometimes slowing, stopping, reversing direction, moving westward for a while before stopping again and resuming its eastward motion. This retrograde motion, this backward wandering, has troubled astronomers for centuries. How can it be explained? If the planets are carried on crystal spheres in perfect circular motion around the Earth, why do they sometimes go backward? The answer, according to the model you have learned, involves epicycles. Mars does not move on a simple circle around the Earth. Instead, Mars moves on a small circle called an epicycle, and the center of that epicycle moves on a larger circle called the deferent. As Mars travels around its epicycle, the combined motion sometimes produces a loop in the sky, a period where Mars appears to move backward against the stars before resuming forward motion. It is mathematically elegant, this solution, but it is also complex, and it requires careful observation to track the actual motion and compare it to the predicted motion. That is what you have been doing night after night, month after month, observing Mars, measuring its position, marking it on the chart, watching it wander. You approach the chart now and study the trail of green marks you have made. Each mark is dated in tiny script beside it. You can see the pattern clearly. Mars has been moving eastward through Leo, from the lion's shoulder toward its paw for the past 2 months. But the motion has been slowing. Mars is approaching one of its stations, a point where it will stop and begin retrograde motion. You need to add tonight's observation to the chart. You need to mark where Mars is now, so that in the future, when you look back at this chart, you will see the complete path, the full pattern of its wandering. You turn to the table and begin to prepare your tools. First, you need to determine Mars's exact position relative to the stars. You saw Mars tonight, of course, while you were on the tower. It was visible in the western sky, reddish and bright, higher than Regulus but not as high as Denebula. But you need more than a general impression. You need coordinates. On the table is another book, an ephemeris, a collection of tables predicting planetary positions. You open it to the page for Mars in February of 1247. The tables give Mars's celestial longitude and latitude for each day of the month. According to the tables, on the 4th of February, Mars should be at 21 degrees 30 minutes into Leo, with a latitude of 1 degree north of the ecliptic. But the tables are not perfect. They are based on observations made years or decades ago, calculated using the epicycle model, and while the model is good, it is not exact. Small errors accumulate over time. That is why you observe, why you measure, why you mark the actual position on the chart. You are testing the model. You are refining it. You are doing the work that will make the next generation of tables more accurate. You take the astrolabe from where you set it down and use it to convert the tabulated position into a position on your chart. The chart is oriented with celestial north at the top and south at the bottom, east to the left and west to the right, the opposite of how maps of the Earth are usually drawn. This is because you are looking up at the sky, not down at the ground, and the directions are reversed. Leo sprawls across the center of the chart, the lion's body formed by a curve of stars, his head marked by the bright star Regulus, his tail ending in Denebula. You have drawn the constellation carefully, consulting older star maps and your own observations to get the positions as accurate as possible. And now you need to add Mars to it. You take a straight edge and a compass and use them to locate the exact position where Mars should be according to the tables. 21 degrees 30 minutes into Leo, 1 degree north of the ecliptic. You mark the spot lightly with a sharp stylus, making a tiny indentation in the vellum that you can feel with your fingertip, but that is barely visible. Then you reach for the inkwell that sits on the table, a small brass vessel with a hinged lid. You open it and look inside. The green ink is still liquid, though it has thickened slightly in the cold. You need to warm it. You hold the inkwell close to the brazier for a moment, letting the heat thin the ink, making it flow more easily. The smell of the ink is sharp and herbal, made from verdigris, the green corrosion that forms on copper in the presence of vinegar. It is not a common color for manuscript work. Most writing is done in black or red or occasionally blue. But you chose green for the planets so they would stand out clearly against the black stars and red ecliptic. Each planet has its own color. Mars is green, Venus is yellow, Jupiter is orange, Saturn is brown, Mercury is purple. The colors help you track them at a glance, help you see the patterns of their motion. You take a very fine quill, thinner than the one you used for writing in the ledger, and dip it carefully into the green ink. The nib fills with the color, and you let the excess drip back into the well. Then you bring the quill to the chart, to the tiny indentation you made with the stylus, and you make a small, careful mark. A dot, a circle, a point of green against the white vellum, exactly where Mars is tonight. The quill scratches softly against the vellum. The ink flows smoothly, controlled, precise. You have done this hundreds of times, marking positions, building up the trails that show how the planets move. Each mark is a moment in time, a snapshot of the cosmos, and together they tell a story. You write the date next to the mark in letters so small they are barely readable. IV Feb. The numbers are cramped, squeezed into the narrow space between stars, but they are legible. That is all that matters. Someday, perhaps centuries from now, someone will look at this chart and read these dates and understand what you were doing, how you were tracking Mars through its epicycle, how you were testing the ancient models against new observations. The ink dries quickly in the warmth of the study. You examine the mark critically, making sure it is exactly where you intended it, making sure the date is clear. Satisfied, you set the quill down and step back to look at the chart as a whole. The trail of green marks curves across Leo like a path through a forest. You can see where Mars entered the constellation 2 months ago, moving steadily eastward. You can see where it is now, approaching the point where it will stop. And you can imagine where it will go next, how it will begin to move backward, how it will trace a loop in the sky before resuming forward motion and eventually leaving Leo behind for Virgo. This is the geometry of the heavens. This is the cosmic choreography, the dance of the wandering stars against the fixed stars. It is beautiful in its complexity, in its mathematical precision. It is evidence of divine order, of a creator who crafted the universe according to rational principles that the human mind can grasp. But there is also something unsettling about it, something that whispers of mysteries not yet understood. Why does Mars wander? Why does it loop? The epicycle model explains the how, but it does not explain the why. What purpose does this motion serve? What message is encoded in these retrograde patterns? These are questions you cannot answer, not with certainty. You can observe and measure and record, but you cannot know the mind of God. You can only see the effects, the outward manifestations, the shadows cast by a greater reality that lies beyond human comprehension. You turn away from the chart and look at the table again. Spread across its surface are other tools, other instruments, other representations of the cosmos. There are books, thick codices bound in leather, their pages filled with tables and diagrams and commentary. There are smaller charts showing specific regions of the sky in greater detail. There are notes and calculations on loose sheets of parchment, held down by stones to keep them from blowing away in any stray draft. And there, near the edge of the table, sitting on a wooden stand, is the armillary sphere. You reach for it now, carefully, reverently. The armillary sphere is one of your most prized possessions, a gift from the monastery's founder decades before you arrived, passed down to you when your predecessor died. It is a model of the cosmos, a three-dimensional representation of the celestial spheres, and it is made entirely of brass. The sphere is perhaps 12 inches in diameter, and it consists of a series of rings, all joined at 2 points representing the celestial poles. Each ring represents a different circle in the heavens. The outermost ring is the meridian, the great circle that runs from north to south through the zenith. Inside, that is the ring for the horizon, tilted at an angle corresponding to your latitude. Inside, that is the ring for the ecliptic, tilted at an even greater angle, showing the path the sun takes through the zodiac. More rings represent the celestial equator, the tropics of Cancer and Capricorn, the Arctic and Antarctic circles. And at the center, suspended on a thin brass rod that runs through the poles, is a small sphere representing the Earth, motionless at the center of creation. The entire structure can rotate. The rings are mounted on axles at the poles, and if you spin them, they move smoothly, gliding around the central Earth, modeling the rotation of the heavens. It is a teaching tool, a demonstration device, a way to visualize the complex geometry of the cosmos in 3 dimensions. You lift the armillary sphere from its stand and hold it in both hands. It is heavy, solid brass, cold to the touch despite the warmth of the brazier. You can feel the weight of it, the craftsmanship that went into its creation. Each ring was cast separately, then carefully assembled and joined with tiny brass rivets. The surface has been polished smooth, though it has tarnished over the years to a deep golden brown. You rotate the sphere slowly, watching the rings move. The meridian stays fixed, but the other rings slide around the poles, carrying their circles through imaginary space. You can see how the ecliptic crosses the equator at 2 points, the equinoxes, where day and night are equal. You can see how the sun's path takes it north of the equator in summer and south of it in winter, creating the seasons. The sphere makes a soft sound as it rotates, a faint metallic squeak from the axles where brass rubs against brass. Squeak, spin, stop. You pause the rotation and examine the position. The ecliptic is aligned with the equator at one of the crossing points, the vernal equinox, the moment in spring when the sun moves from south to north, when winter ends and summer begins. You rotate the sphere again, moving it to show the summer solstice, when the sun is at its highest point, 23.5 degrees north of the equator. Then the autumnal equinox. Then the winter solstice, when the sun is at its lowest, 23.5 degrees south. Then back to the vernal equinox, completing the annual cycle. This is how you learned astronomy, by playing with models like this, by visualizing the motions, by making the abstract mathematics concrete. The sphere shows you what the numbers mean. It shows you why the sun's altitude changes through the year. It shows you why the length of day and night varies with the seasons. It shows you why certain stars are visible in summer, but not in winter. And it shows you the zodiac, the 12 constellations that lie along the ecliptic, through which the sun appears to move as the year progresses. The zodiac is marked on the ecliptic ring with symbols, small engravings that represent each constellation. You rotate the sphere until you can see them clearly in the candlelight. There is Cancer, the crab, represented by a simple drawing of a crab with 2 claws. The sun enters Cancer at the summer solstice, when it reaches its northernmost point. Cancer is followed by Leo, the lion, shown with a flowing mane and a curled tail. Then Virgo, the virgin, depicted as a woman holding a sheaf of wheat. Libra, the scales, is next, a simple balance with 2 pans. Then Scorpius, the scorpion, with its curved tail and stinger. Sagittarius, the archer, shown as a centaur drawing a bow. Capricornus, the sea-goat, a strange creature that is half goat and half fish. Aquarius, the water-bearer, pouring water from a jug. Pisces, the fishes, 2 fish tied together by a cord. And then the spring constellations. Aries, the ram, with its curved horns. Taurus, the bull, charging with head lowered. Gemini, the twins, 2 figures standing side by side. And finally back to Cancer, completing the circle. These symbols are ancient, older than Christianity, older than Rome, older than Greece. They come from Babylon, from the priest astronomers who watched the skies thousands of years ago and saw in the stars the shapes of animals and gods and heroes. The zodiac was their calendar, their way of marking the passage of time. and it has been passed down through the centuries, preserved and refined, until it became the system you use today. But the zodiac is not just mythology, it is practical. It is a calendar of the harvest, a way to know when to plant and when to reap. When the sun is in Aries, it is spring and you plant the grain. When the sun is in Cancer, it is summer and the crops grow. When the sun is in Virgo, the virgin with the wheat, it is time to harvest. When the sun is in Capricornus, it is deep winter and you survive on what you stored in the autumn. Farmers do not need to understand the mathematics of the ecliptic or the geometry of the celestial spheres. They only need to know the signs. When the sun rises with Taurus, do this. When the sun sets with Scorpius, do that. The stars are a clock and a calendar written across the sky, readable to anyone with eyes and patience. You set the armillary sphere back on its stand and step back, looking at it. The brass rings catch the candlelight and glow warmly. The shadows of the rings fall across the table in complex patterns, circles within circles, a miniature cosmos rendered in light and dark. There is something deeply satisfying about these models, these representations. They take the vast and incomprehensible universe and make it small, portable, understandable. You can hold the cosmos in your hands. You can spin it with your fingers. You can trace the paths of the sun and planets through their appointed courses. And yet, you know that the model is not the reality. The real cosmos is infinitely larger, infinitely more complex. The brass rings of the armillary sphere are not actually there in space. They are imaginary constructs, geometric abstractions that help the mind grasp what it cannot directly perceive. The true crystal spheres that carry the planets, if they exist at all, are invisible, intangible, known only through mathematics and faith. You move to the window now, a narrow opening in the wall with wooden shutters that you can open or close. The shutters are closed against the cold, but you want to see the sky again, to check the time, to observe how the night is progressing. You pull the shutters open and look out. The darkness is less absolute than it was. The east is showing the first faint hint of lightning, not yet dawn but the promise of dawn, the subtle shift from black to deep blue that comes in the hour before sunrise. The stars are still visible, but they seem dimmer now, less brilliant, washed out by the growing light. You realize with a start that you have been working longer than you intended. Hours have passed since you descended from the tower. The calculations, the chart, the contemplation of the instruments, all of it has taken time, and now the night is nearly over. Soon the sun will rise. Soon the stars will fade completely. Soon the bell will ring for lauds, and the monastery will wake. You should sleep. You are exhausted, bone-tired from the cold and the concentration and the long hours of work. Your eyes ache. Your back aches. Your fingers are stiff and sore from gripping the quill and the astrolabe. But there is a satisfaction in the exhaustion, a sense of completion. The work is done. The observations are recorded. The chart is updated. The cosmos has been measured and mapped for another night. The universe is in order, or as much order as you can impose on it with your limited tools and understanding. You close the shutters and turn back to the study. The brazier has burned low again, the coals fading to ash. The candle is a stub, the wax pooled around its base, the flame guttering in its own melted remains. You should extinguish it before you leave, but you pause, reluctant to end the night, reluctant to return to the ordinary world of sleep and meals and prayers. There is something about these solitary hours of astronomical work that feels sacred, more sacred even than the liturgy in the church. In the church, you chant the words that countless others have chanted, following the prescribed forms, participating in the communal ritual. But here, alone with the stars and the instruments, you feel closer to the divine mind, closer to the fundamental truths of creation. The stars do not lie. They do not dissemble or obscure. They simply are, moving through their appointed courses with mathematical precision, indifferent to human observation, but available to it, offering themselves up to be measured and understood. In studying the stars, you are studying the thoughts of God made manifest in matter and motion. This is why you do this work. Not for fame or recognition, though those would be welcome. Not for practical application, though the calendar and timekeeping are useful. You do this work because it brings you closer to truth, to the underlying order of reality, to the rational structure that supports and sustains all of existence. You blow out the candle. The flame vanishes and darkness rushes in, though not complete darkness. The coals in the brazier still glow faintly, providing just enough light to see the outlines of the furniture, the shape of the room. You stand in the dimness for a moment, letting your eyes adjust, letting the silence settle around you. Then you open the door and step back into the scriptorium. It is even darker here, the fire in the hearth completely dead now, the room cold and still. You make your way carefully to the door that leads to the dormitory, moving by memory and touch, feeling your way along the wall. The dormitory is a long, narrow room lined with small cells, each cell containing a simple wooden bed with a straw mattress and a wool blanket. Your cell is near the end, and you enter it quietly, not wanting to disturb the monks sleeping in the neighboring cells. The cell is tiny, barely large enough for the bed, and a small wooden chest where you keep your few personal possessions. You sit on the edge of the bed and remove your outer robe, folding it carefully and setting it on the chest. The room is freezing, and you can see your breath clouding in the air, but you are so tired that the cold hardly registers. You lie down on the mattress, pulling the blanket over yourself, and close your eyes. The darkness behind your eyelids is complete, absolute, the same darkness that filled the stairwell descending from the tower. But it does not feel oppressive now. It feels restful, peaceful, the natural darkness of sleep and rest. You can still see the stars in your mind's eye, the patterns of the constellations, the trail of Mars across Leo, the brass rings of the armillary sphere. They are imprinted on your consciousness, part of your internal landscape, as familiar as the faces of your brothers or the layout of the monastery. Outside, the sky is growing lighter. The stars are fading one by one, the fainter ones first, then the brighter ones, until only Venus and Jupiter remain, the morning stars heralding the sun. And then they too vanish, swallowed by the growing light of day. The sun rises. It clears the eastern horizon and begins its daily journey across the sky, following the path of the ecliptic, moving inexorably through the zodiac. Right now it is in Aquarius, the water bearer, but in a few weeks it will move into Pisces, and then into Aries, and the spring equinox will come, and the cycle will continue. The firmament rotates above the monastery, carrying the stars westward. They are still there, of course, even in daylight. The sun's brilliance merely renders them invisible, overwhelms them with light. But they are there, holes in the floor of heaven, and tonight when the sun sets they will reappear, and you will climb the tower again, and you will measure them again, and the work will continue. For now, though, you sleep. The universe is in order. The measurements are recorded. The calculations are complete. The charts are updated. Everything is as it should be, as it was ordained to be from the beginning of creation. The spheres turn in their appointed courses. The planets wander through their epicycles. The stars maintain their fixed positions. And you, a small figure in a small cell in a small monastery on a hill in medieval Europe, rest. You have done your part. You have observed and measured and recorded. You have added your tiny contribution to the great edifice of knowledge that humanity has been building for thousands of years. Your breathing slows, your muscles relax. The tension drains from your body, replaced by a deep, profound weariness. You sink into the mattress, into the darkness, into sleep. The bell will ring soon. Lauds will begin. The monks will rise and shuffle to the church, and you will rise with them, and you will chant the psalms, and you will break your fast, and you will attend to your duties. But that is later. That is the future, hours away, in another part of the cycle. Now there is only darkness, only warmth beneath the blanket, only the soft sound of your own breathing, only the drifting sensation of consciousness dissolving into sleep. The stars have set, the night is over, the work is done. You are safe. The cosmos turns above you, vast and cold and beautiful, indifferent to your sleep, but somehow protective of it. A great ordered mechanism that includes you, that holds you, that keeps you in your proper place in the scheme of creation. Sleep comes like a tide, gentle and irresistible, pulling you down into its depths. Your last conscious thought is of the stars, always the stars, the eternal fixed points that will be there tomorrow night and every night after, waiting to be observed, waiting to be measured, waiting to tell their ancient stories to anyone patient enough to listen. The universe is in order. You are safe. Sleep.